In this video, I'm going to demonstrate how to find a scalar triple product of three vectors in component form. I have my vectors A, B and C, and I'm trying to perform the operation A dot B cross C. It's important to remember when we're doing these that the cross product has to be performed first. If you were going to substitute each of these in and do the thing manually, cross product must be done first to produce a vector, and then it makes sense to have a vector A with a dot product of another vector. If we were to do the dot product first, we'd end up with a scalar cross a vector, and that doesn't make sense. Now, this one is each of these vectors has three non-zero components. We would be better off setting up a matrix to do this, and the rows of the matrix are the values of each component. 2, 3, 2, negative 2, 2, negative 1, 2, 1, 1. If we find the determinant of this matrix, we will have the result of our scalar triple product. So I'll work my way across the first row. The first entry is 2, and I multiply by the submatrix that excludes this row and column. So that's 2 minus negative 1. Put the 3 next. It's always subtract on the second term, so it's plus, minus, and then the next one will be plus. They alternate. So excluding the column and row that has the 3, the submatrix is 2, negative 2, 2, negative 1, 1. So minus 2 by minus 2, subtract minus 2. Third one's always positive. Third term here is a 2. And my submatrix will be this 4 elements, negative 2 minus 4. So I evaluate this. 2 minus negative 1, that's the same as 3. 2 3s, that's 6. Negative 2 plus 2 is nothing. The entire middle term will be nothing. Minus 2 minus 4 is minus 6. 2 times minus 6 is minus 12. So my answer is negative 6. Now that's a scalar triple product. Like any scalar product, could be a positive, 0 or a negative answer. In the case where we're using these to do the volume of a parallelepiped, we would simply find the absolute value of this, because it wouldn't make sense to have a negative volume. But this is not a volume, this is just a triple product, so negative 6 is the correct answer in this case.